So again, read the question carefully. A particle P, mass 6 kilograms, under the action of two forces, F1 and F2, where F1 is that, F2 is that, P and Q are constants. The acceleration is 3 minus 2j. Find to one decimal place the angle between the acceleration and I. So I would encourage you to draw these. We usually define I as horizontally across the page, J as up the page. You might say horizontal and vertical, depends on the context. And so we know that this vector A is 3 across, and 2 down. Find the angle between I, so this is our I direction here. Yeah, this is the I direction here. So we want the angle with this vector. So that's going to be there, theta. Notice the way that I have joined the vectors nose to tail, because it's one followed by the other, if you like, to get what happens. It's not, yeah, it's not 3 minus 2, and then that join those two up somehow, yeah? So it's not that. It's not applied at that point. You have to think of the vectors added up, this one and then this one, as I've drawn them. So it's always this nose to tail idea. Okay, we've got the opposite and the adjacent, so that's our opposite. That's adjacent to the angle, so it's tan. So we know tan of theta equals 2/3. Theta equals arc tan of 2/3. You can tap that in the calculator. I've not got one with me. And that actually, on this occasion, answers the question, because it just says find the angle between the acceleration and I. I would prefer to see the answer usually would need to be given theta is equal to whatever arc tan of 2/3 is. Check it on a calculator. And then we'd say clockwise from positive I, if we needed a direction, yeah, because otherwise it's just an angle. If it's a direction, it needs to be given from somewhere. Okay, part B, find the values of P and Q. Okay, so here we need to remember a bit of our mechanics, and it's common for odd little pure or odd little stats questions to crop up on the pure element of the course. So just be aware of that. Okay, so find P and Q. We need to remember N2, F is equal to MA. The squiggles show that they're vectors. So we've got F1, which is 8 minus 10. I would switch to column vectors. 8, negative 10, plus F2, which is PQ. PQ is equal to the mass, which is 6, times the acceleration, which was 3, negative 2. Okay, expand it. So if we take the I components, we get 8 plus P is equal to 18. That implies P equals 10. Minus 10 plus Q equals negative 12. So that implies Q equals negative 2, adding the 10 across. So we've found P and Q. That was straightforward. Find the magnitude of the resultant force R. I have to simplify your answer fully. So C. R is then the magnitude of R is equal to the magnitude of 8 minus 10 plus 10 minus 2, which is equal to the magnitude of 18 minus 12. And that we're going to use Pythagoras on. So it's negative 18 squared. Sorry, not negative 18 squared, not that it matters, it's positive 18 squared plus negative 12 squared. You can use a calculator for that, simplify it down. I'm going to think of that as 6 squared times 3 squared plus 6 squared times 2 squared. I'm then going to take the 6 squared out and square root it, leave 6 times 9 plus 4, so we get 6 root 13 as our answer. It's fully simplified, but you can use a calculator if you need to.